This is your 1.1.2 homework. So we're wrapping up section 1.1, and we want to know what type of reasoning this is talking about, inductive or deductive. So just a reminder that inductive reasoning starts with specific cases and then moves to a general conclusion. So that's inductive. And deductive works the opposite. We start with general overlying ideas and move to something specific. Okay. Oh, sorry. There you go. All right, so the logic here says my television did not work 2 nights ago. My television did not work last night. Therefore, my television is broken. All right, so these are specific instances that are only related to you, right? Not a general overlying thing about all televisions. This is a specific, or sorry, I'm not saying specific. This is an inductive form of reasoning because we cannot guarantee that the TV is broken. Maybe you lost power in your house, or maybe, your battery remote is broken, or is dead or something like that. We cannot guarantee that it's the TV that's broken. Could be a lot of other things going on. It's inductive. All right, the statement, all roads lead to Rome, and Route 66 is a road. Therefore, Route 66 leads to Rome, is a deductive logic statement, deductive reasoning. And if you want to think about, we were talking about all the roads. So here's roads. They lead to Rome, and then we got Route 66 in here. All right, so then Route 66 leads to Rome by this logic. And I know that's not true, but the logic is deductive. We start with a big general statement, and then we get more specific to a specific conclusion. Then Margaret has 5 cats. Margaret has an Instagram for her cats. Therefore, Margaret likes cats. All right. Is that deductive or inductive? Well, this is just assuming things about a particular person, but we cannot guarantee that Margaret likes cats. So this is inductive. Okay. Next, inductive reasoning, assuming a general result given a series of specific events. The conclusion of an inductive argument is never guaranteed. So for these, you guys, you kind of pick the pattern that you want to do. Like all these answers could be different. I'm just going to go with what I see. So I'm going to kind of talk through it. But like, again, these could be anything that you want because they're never guaranteed. When I look at 2, 3, 5, and 7, that could be like the ages of kids I babysit. Okay, so then maybe the other ones are like, 8, 9, 10 or something like that. Okay, what I think that this is actually going for is prime numbers. So 2, 3, 5, 7, those are all prime numbers in order. The next prime number would be 11, and then 13, and then 17. But that's, it's not guaranteed. What if it had been talking about, I don't know, the ages that you went to Disneyland or something, or the number of months since you've seen like cousins or something like that. I don't know. It could be all sorts of different things, different numbers. That's what I went with. Prime numbers. All right, 1, 8, 27. What could those have in common? And I jump to, this could be 1 to the third, and then 2 to the third, and then 3 to the third. So it's, multiplying by thirds each time. So, my next one would be 4 to the third. And 5 to the third, and then 6 to the third. Oops. So I'm going to write those in. But that doesn't have to necessarily be the case. 1, 8, and 27 could be like, appointments that you have, like doctor's appointments that you have are on the 1st, 8th, and the 27th. And so then your next doctor's appointment could be, the second and, over the next month and things like that. So not guaranteed, but that is the rule that I used. And if you guys do something different, just tell me what you used. All right. Your last thing is to complete this Sudoku puzzle. Okay, so if you're really, really stuck with this, I will do this. It took me, I don't know, a couple minutes the first time I did it. And I'm just going to walk you through what I'm thinking when I do the Sudoku puzzle. So you just have to start somewhere. And I like finding pairs like this that match so I can narrow it down to a different row. So like in this row, the 6 is already gone. And in this row, the 6 is already there. So we can't have a 6, but we need a 6 in this middle row. We can't use this box or this box. So it's got to be in this box. In the middle row, that leaves these 2 squares. And there's already a 6 there. So by my deductive reasoning, that needs to be a 6. Right? And that works. That lines up. So then let's see if I can get another 6. I have a 6 here and a 6 here. So then it's in the middle in this column over here. There's only one spot. So that's got to be a 6. All right. Then let's see. A 6, 6. The 6 already is in this one. I know it's got to be in this column. But there's a 6 here. So the only spot for that is right here. All right. 6s are in these rows. So it's got to be in this top row in this box. Right there, and I think I got all of them. So those are all the 6s. Hooray! Let's see if I can do that with another. I have 1s down here. I don't know why I always start down here. It's just kind of what I do. So this row has a 1, this row has a 1. So then it's got to be in this row, and it's got to be in this square. And this one has a 1, so it's got to be right there. All right. 1, 1. So this row has a 1. Got to be in this box, can be either here or here, so I'll have to wait on that. Here's a 1, 1, here's the middle one then. 1, 1. Got to be in this row right there, and so then all of a sudden, yes, I can say that's the 1, and I got all the 1s. All right, so I really like to use like 2 columns to kind of eliminate things. If you guys are seeing that pattern, that's pretty cool. Then I go to like, what are some things that are really filled up? Like this whole row needs the numbers 1 through 9. So 1, 2, 3, 4, 5, 6, 7. So it's got to be an 8 and a 9. It cannot be an 8 here because there's the 8 for this box. So this has to be the 8. That's the 9. Okay. Then let's see. This box has a lot here. So I've got 1. Can't be a 2 there. Can't be a 2 here. It has to be a 2 here. And the reason I know it can't be a 2 here is because of this. It can't be a 2 there because of that. I need a 3. Cannot be a 3 in this one, so this has to be a 3. And then the 4 is the only other one missing. All right, cool. Let's see. 1, 2, 3. Can't be a 4 here because of that. So 4's maybe here. Cannot be a 5 here, so this has to be a 5. And then this has to be the 4. What am I missing? A 7. All right. Then I've got, let's see, 1. I'm going down this row. I've got a 1. I don't have a 2 yet, but it cannot be a 2 in this box. So that's got to be a 2. 3, 4, 5, 6, 7, 8. So it's got to be a 9. Then let's see. 1. I like this one. Let's get in here. 1. I need a 2. Can't be a 2 there. So either here or here. 3, 4. Not be a 5 here. But it could be either of those. Okay. 6, 7, 8, and then 9. Can't be a 9 there, so this has to be a 9. Okay, then I can try this again. 1, this has to be a 2, 3, 4, 5. So if you get 1, then some more open up, things like that. 1, 2, 3, 4. Either of these, this has to be a 5. Can't be in this column, and it can't be in this row, so it's got to be that one. 6, 7. got 8 and 9 left. Cannot be an 8 here, so this has to be the 8. And that's the 9. Wonderful. That 8, 8. I don't have that yet. Okay. 1, 2. Cannot be a 3 here, so that's here. And this one's got to be a 4. 1, 2. Need a 3. Got to be here because that column already has a 3. 4, 5, 6. All right, 7 and 8 are my leftovers, but the 8's got to go here because 7's already taken, and 7's got to go there because the 8's already taken. We're getting close, you guys. 1. This has to be the 2 because this column took that 2, this row took that 2. 3, and then I need a 4. This has got to be it. And this has got to be a 5. 1, 2, I need a 3. It's got to be there. 4, 5, 6, 7, 8. There's a 9. In this box, I need a 2. Cannot be here. Cannot be there, so it's there. 1, 2, 3. I need a 4. Cannot be here because of that, so it's here. 7, 8. All right. This one's missing 1, 2, 3, 4. It's missing a 5. 1, 2, 3. Oh, here. 1, 2, 3. This is the 4. 1, 2, 3, 4, 5, 6. I need a 7 and a 9. 9's got to go there. 7's there. Last little box, we got this. 1, 2, 3, 4. I need a 5, but I've already got those, so 5 goes there. I need an 8. The 8's already gone from here, so that's there. And 9. And we did it.